Okay, so for example 26, it says consider the differential equation dq dt is equal to 1/8 40 minus q. And in this case here now we're dealing with q's and t's, not y's and x's, but you just have to lock it in your mind that q takes the place of y, t takes the place of x. I have many times just in the process of sketching out my ideas, I've let the q be y. I've just put y's and x's in and did it that way. But it's a good habit to get into in the final answer, writing it back with q's and t's. We're given the initial condition q of 0 is equal to 5 and asked to find the domain of the solution. So we're going to start off separating these variables, bringing the q's to the left by dividing by 40 minus q, moving the dt to the right. So I get 1 over 40 minus q dq is equal to 1/8 dt. We integrate both sides. So 1 over 40 minus q dq is equal to the integral of 1/8 dt. Now we do have an issue here because we have a composition here with the quantity 40 minus q and the reciprocal function. So if u is going to be this 40 minus q, the derivative of u, or du, would be -1. So I do need to bring in a -1 here before my dq, balancing it with a -1 on the outside. So now we can integrate and say that it's going to be -1 over u du integrates to the ln of the absolute value of u, so 40 minus q, equals 1/8 t plus c. Okay. So we're going to go ahead and take our initial condition of 0, 5 and substitute those values in and try to find our constant of integration. So I get negative ln absolute value 40 minus 5 equals 1/8 0 plus c. So on the right hand side I get c, on the left hand side I get the negative ln of just 35. So my function becomes negative ln of the absolute value of 40 minus q equals 1/8 t minus the ln of 35. Our first step to solving is to get rid of this -1 out front, so we can multiply both sides by -1. So I have the positive ln now, absolute value 40 minus q equals, and both of these are going to switch. The 1/8 t will become negative, the negative ln of 35 will become positive. So I'm just going to go ahead and swap the order of those just to keep the negative tucked inside. So this is a 1/8 over here. To cancel the ln, we exponentiate both sides, so the e will cancel with the ln, giving me the absolute value of 40 minus q. And on the right hand side, I get e to the, I'm going to go ahead and write it, ln of 35 minus 1/8 t. And let's not forget this minus is really just adding a negative. And the reason I wrote that is because I can now split this into e to the ln of 35 times e to the negative 1/8 t. So the e to the ln of 35 just becomes 35 times e to the negative 1/8 t. Now, when I get rid of this absolute value, does the 40 minus q equal the positive version of this? Or does 40 minus q equal the negative version of this? And we use the initial condition to determine that. So in other words, is the point 0, 5 on the function on the left, or is it on the function on the right? So if I plug 0 in here, 0 times negative 1/8 is 0, e to the 0 is 1. So I get 35. 40 take away q is 5. 5 does give me 35. Over here on the right, we would have got negative 35, and 40 take away 5 is not negative 35. So our function is 40 minus q equals 35, e to the negative 1/8 t. We're going to subtract 40. And now multiply both sides by -1. So I get q is equal to, and I'm going to do the same thing here. This would become negative, this would become positive. So we get positive 40 take away 35e to the negative 1/8 t. And the domain, well, since our only variable over here, only t is in the power of e, the domain of the exponential function is all real numbers, so our domain is going to be negative infinity to infinity. Okay, and that's example number 26.